Well, welcome to my session, More Things in Active Directory That Can Affect Your Desktop and Application Virtualization Efforts and How to Fix Them. Of course, the title alone is about as long as the session. And please tweet about this. That way my wife knows I'm actually in London and my mom can actually believe her son is being a productive member of society. My name's Webster, and if you can't tell by the accent, I'm an independent consultant based out of Nashville, Tennessee. I've been a CTP since 2010, and I run the website carlwebster.com, otherwise known as the Accidental Citrix Admin, because if you ever find me being an administrator on your Citrix farm, that is purely an accident waiting to happen. And there's my email address, Twitter, Facebook, LinkedIn. It's all pretty easy. Just about everything is Carl Webster. Now, before we continue, just want to let you know, so you're not scrambling, trying to write down notes, take pictures of slides and stuff like that. I got a free PDF that have all my notes, comments from the directory services experts who reviewed this presentation for me. All that will be available, if my time zone conversion is correct, about 15 minutes before this presentation is over. This PDF will be on there. It's 101 pages long. So lots of information on there. And I think I'm up to around 90 references at the end of the PDF. So there's a lot of information in the PDF. This session is sort of a continuation and a wrap-up of all the presentations I did last year. And when we ended the presentations last year, we talked about the session last year was 10 things in Active Directory that can hurt and all that. We wound up with 10 solutions to keep failure away. And we decided we were going to check our domain and force functional levels, make sure all domain controllers are global catalog servers, no manually created connection objects in sites and services, check the netlogon.log file for missing subnets, create reverse DNS lookup zones for all subnets in sites and services, clean up DNS of unnecessary duplicate host names and IP addresses, clean up orphan domain controllers, make sure the PDC emulator is configured properly, make sure all domain controllers have their DNS IP settings configured properly, and use Microsoft's and other vendors' Active Directory design guidelines. And out of those 10 things, I got 2 questions that were asked over and over. And I have done numerous Active Directory assessments since then and helped people clean up Active Directory for their desktop virtualization efforts and when they're bringing in like AppV and stuff. The second most asked question, all right, you covered single domain, single site IP configuration stuff for domain controllers, but what about single domain, multiple sites, and multiple domain, multiple sites? What all issues do they have with all of those 10 things? And the most frequently asked question by far, hey, after your session, I went back to work on Friday, I configured DNS aging and scavenging, and I came back to work the next day, and all the old DNS records were still out there. So why aren't the old DNS records being deleted? It's a good question. So we're going to start off with question number 1. And for that, we're going to cover the basics of aging and scavenging. When can scavenging start? Aging and scavenging for a sample record. How DHCP fits into all of this. And then we'll put it all together. Now, one thing, scavenging just means deleting. But if Microsoft had actually called this aging and deleting, people would have freaked out. So they use a euphemism, scavenging. It makes it sound less dangerous. So aging and scavenging actually means we're going to age DNS records and then we're going to delete them. To start off with, we're going to talk about the current server time. Now this is very important because this actually, as simple as this actually confuses people. We're talking about 2 different things. The current server time on the DNS server that registers a DNS record and on the server that is set for scavenging. That determines when scavenging calculations are based on and therefore when scavenging will take place. So you need to have accurate time in your network. The resource record timestamp. This is when the record is created, and in my sample record here, you see it has a time of 10 a.m. if I created this record at 10:59:59, it will show a timestamp of 10. It rounds down to the nearest hour, always rounds down. Now, by default, resource record timestamps are not shown. So you have to go to View and then Advanced in order to see timestamps. People freak out. We don't have timestamps. You know, something's wrong in our DNS. Nah, Advanced will allow you to see that. So what about static IPs and static DNS records? Because most of us, your XenApp servers, your controllers, stuff like that, you're going to have a static IP address set on those servers. But then you can also create static DNS records. So here's a computer with a static IP. The computer with a static IP actually gets a dynamic DNS record. Dynamic means it's created into DNS dynamically. You didn't create it, it created it. And it has a timestamp, and it has the checkbox, delete this record when it becomes stale. When I create a static DNS record, that is a DNS record that has an IP address, and you created it, and it will never be touched by aging and scavenging if you don't screw things up. Because you can see the difference here. I don't have a timestamp, and the box, delete this record when it becomes stale, is not set. What about domain controllers? Domain controllers have static IP addresses, so they should be dynamically registered, and they are. But because domain controllers are special, they do not get a timestamp. And obviously, you don't want their records being deleted from DNS, so the checkbox is not set. Now here's the way you can really screw things up. People get impatient. They turn on aging and scavenging. They come back to work the next day thinking that just by turning all this on, they come in the next day and all the old records are going to be gone. It doesn't happen that way. So then they go and they run this command, age all records. So think about that. Aging and scavenging is deleting. And now you're going to tell it to age all records so they can be deleted. And it will do exactly that. It will now take your record that you created with a static DNS, and now it has a timestamp. And now it has been flagged to be deleted from DNS when it is stale. If your Active Directory is perfect and has absolutely no issues and no flaws, this will take care of itself. I'll explain how in just a little bit. Now, the next thing we're going to look at, no refresh interval. In DNS, records are continually refreshed. And to keep replication traffic down to a minimum and the number of writes to the Active Directory database to a minimum, DNS says, I'm going to accept no refreshes for 7 days. You can just talk to the hand. Going to be no refreshes accepted. Updates will be accepted, and I'll explain the difference in just a little bit, but no refreshes will be accepted for the default of 7 days. The refresh interval, 7 days. During this 7 days, DNS says, I will accept refreshes, and I'll also accept updates. So now we've got 7 days and 7 days. So we're up to 14 days now. The next, start scavenging time. This is the time that the server you configure as your DNS scavenging server says that I'm going to take the current time on this server plus the refresh interval and set scavenging. When I set this up, I had everything done on April the 13th. So when I got through all the aging and scavenging stuff, you remember my resource record I created was created on April 13th at 10 a.m. So the scavenging time is set for 7 days later, April 20th at 10 a.m. The scavenging period. This is the time that DNS says, hey, all right, if a record, we're not going to accept any refreshes for 7 days. Then it has 7 days to be refreshed. If it hasn't refreshed, then it's now stale. And we're going to sit here for 7 days and let it be stale. And at the end of this period, I'm going to run the scavenging process and I'll get rid of those stale records for you. Record refresh. Refreshes can generally occur for the following reasons. When the computer started, its current name and IP address equals its previous name and IP address. That's a refresh. During the no refresh period, this is ignored. During the refresh period, if we're on day number 8, because we got the 7-day no refresh, and then we're starting the refresh period of 7 days, say on the first day of the refresh cycle, that's day 8 in our calendar, if the computer actually is refreshed at that point, we go all the way back to day 1 again, and no more refreshes will be accepted at that computer for 7 more days. A periodic refresh is sent by the computer while it is running. Prior to Vista and Server 2008, the DHCP client refreshed the IP information. From Vista 2008 forward, it's actually the DNS client service that does the refreshes. For all computers, whether they're servers or just other computers, they are refreshed every 24 hours. Domain controllers are different. They are refreshed every 60 minutes because of how important they are. It's going to go through and make sure that all of its SRV records are correct. And the SRV records are where it says, I'm a domain controller, I do LDAP and here's my port. I'm a global catalog server and here's my port. I handle Kerberos and here's the port for Kerberos, and on and on and on, depending upon what you got in your environment like Exchange and SharePoint and so forth. And other network services can make refresh attempts. The DHCP server, cluster servers. The cluster service is continually refreshing DNS for all of the nodes that are in the cluster. And then the NetLogon service on domain controllers is continually refreshing the DNS record for domain controllers. Now, what are updates? Updates occur for the following reasons when a new computer is added to the network. It's obviously going to get an update sent to create a record with its host name and its IP address and timestamp and everything in DNS. And when the computer starts, if the current name and IP does not equal the previous name and IP, that is an update. So even during the no refresh period, if one of these events happens, it's going to update DNS. And then when the NetLogon service registers new domain controllers, it's going to go through and create all the appropriate SRV records. And then every 60 minutes, it's going to make sure all that stuff is still out there. When you run that command, age all records, it actually changes domain controllers also to a timestamp, and that box is checked. But the NetLogon service says that's not supposed to be set for domain controllers, so it clears them. And in my little lab environment, I just had 5 2012 domain controllers. I would run that command, and I could never get a screen capture fast enough before it cleared the stuff. Because I was trying to show you that when you run that, it actually affects domain controllers, but it clears it so fast, I couldn't get a screenshot. Scavenging servers. This is an optional and highly recommended setting. The reason? When you go through and you set all the aging and scavenging stuff in DNS, most people will set on every server, enable scavenging. Well, what that means is that every DNS server will now scavenge. And then you're going to have a lot of replication traffic happening, and you're going to have a lot of collision and change detection going on within Active Directory, because this scavenging server, this DNS server, will have deleted the record, but it hasn't replicated yet over here, so when it gets replicated, this one says, I haven't scavenged it yet. But yet it's been deleted, so which one is the most current and which one's accurate? So to prevent that and prevent all that traffic and replication traffic, they recommend that you set 1, maybe 2 at the most, servers to be scavenging servers. And there's also another good reason for this. If something goes wrong in aging and scavenging, would you rather have one server and one set of event logs to check? Or would you rather go around to every DNS server in your environment trying to figure out where the issue is? I would rather have one place to check. So Microsoft highly recommends this. So when can scavenging start? Now this, don't worry about that. You'll read that in the PDF. But there are 5 things that will set when the start scavenging time can be set. Now this is dual wording, so I'm going to word these to you 2 ways. When dynamic updates are enabled for the zone, if everything is set properly for aging and scavenging, but you don't have dynamic updates set, the start scavenging time will never be set. Wording number 2, if everything is set properly, then you go in and set dynamic updates for the zone. Then the start scavenging time will be set. Enable automatic scavenging of stale records. If you have everything else set, but this isn't set, start scavenging time is not set. Once you set this and everything else is correct, the start scavenging time will be set. The DNS server loads a primary zone that is enabled to use scavenging. Not everyone uses Active Directory integrated DNS. Matter of fact, Mark Manasseh in his classes, he tells people he doesn't use it. I don't know, I think he's afraid of it or something, but he doesn't use it. And there are a lot of people that use primary and secondary zones for their Active Directory. And there's absolutely nothing wrong with that. But primary zones can be loaded from a file. And at some customer sites, that file can contain many tens of thousands or hundreds of thousands of records. If a domain controller is running DNS and it's also a global catalog server, global catalog is an in-memory cache of a partial representation of every object in your Active Directory forest. DNS is an in-memory cache. So if you've got a large Active Directory network, the last thing you want is a 32-bit domain controller. Because if global catalog is loading a partial representation of every user, computer, security group, distribution group, universal group, whatever, in memory on that domain controller, and you would probably be surprised how many people still running Server 2003, 32-bit, 1 gig domain controllers and wondering why Active Directory performance sucks. So when you have a zone file that has tens of thousands or hundreds of thousands of records, it can take hours for that to load. And until it is completely loaded, the start scavenging time will not be set. And once the zone completely loads and is validated, the start scavenging time will be set. When the zone resumes service after having been paused. I don't know why, but some people pause their DNS zones. And so if the zone is paused while you're configuring all this aging and scavenging stuff, the start scavenging time will not be set. So after you've gone through all of that and then you start the zone, then once it goes out and verifies that all the other aging and scavenging stuff is done properly, then the start scavenging time will be set. If the zone is Active Directory integrated, replication must have occurred once. When the zone is Active Directory integrated and aging and scavenging is not enabled, resource record timestamps are not replicated. Active Directory is smart enough to know that if you're not using aging and scavenging, which is off by default, it's not going to bother with all the traffic replicating resource record timestamps. So once you enable aging and scavenging, it is possible because the DNS server that registers the resource record sets the timestamp. So you could have DNS server 1 register the record on April 13th, And then DNS2 could have registered the record on April 22nd. And now you get 2 DNS servers because timestamps are not replicated by default. They don't know they're different. So when you enable aging and scavenging, replication has to happen so that the server you have set as the scavenging server can get all those records in and start taking a look. Oh, I've got 4 records for server 1. Which is the most current? Which has the most current resource record timestamp? That's the one I'm going to keep, because you don't want to keep in any of the others, because that record could then be scavenged and then deleted out of DNS. So when all the previous events occur, the DNS server starts the value of the start scavenging time by calculating the current DNS server time plus the refresh interval equals the start scavenging time. That is why having accurate time in the PDC emulator being configured properly to be the authoritative time service for your domain is very critical, because it affects the resource record timestamps. It affects the scavenging process. And then once it's done, you'll get that. Now, there are a couple other items that are not listed in the Microsoft documents that will also affect the start scavenging time. Restarting the scavenging server. If you restart the scavenging server, it comes up and says, what's my current date and time? What's the refresh interval? That's the new start scavenging time. So if you're in the habit of doing weekly reboots, like a lot of people are, the start scavenging time will continually be changed. Restarting the DNS server service on the scavenging server. This one puzzles me. When I was doing all my research for this presentation, there are lots of articles, conflicting articles from MVPs and professional field engineers for Microsoft, Microsoft TechNet and KB articles and MSDN articles, and people would comment, oh, this aging and scavenging stuff, it's not working, something's wrong, the scavenging process never does. And come to find out that the people were in the habit, they had a scheduled task that went every night on their DNS servers and restarted the DNS server service so that it could flush the cache and clean up the memory on the DNS server. When it did that, it reset the start scavenging time. So if you're in the habit of doing either one of these, scavenging will never take place, because the time is always reset another 7 days, another 7 days, and it never happens. Kind of like balancing government budgets. Never happens. So let's do a sample record. So what I did to do this is I actually created a Windows 7 VM. And I brought it up, I joined it to my DC 2012 lab Active Directory, and once everything was settled and the record was registered and everything, I just did a forced shutdown on the VM, because I wanted to make sure the DNS record stayed out there and that it didn't have any chance for DHCP or any other process to release the record. And what I see in a lot of desktop virtualization projects is people will go out there and they'll be working on an image and they think they got it working, and they'll power it up, it joins the domain and everything, and then something hangs, something doesn't work, and they can't get into it, but yet it's registered in DNS, so they just force shut it down, they delete it, and they start over. The next thing you know, they've got hundreds of records in DNS because of this. So to emulate that, I just created one and shut it down. So the first thing is the no refresh. So DNS is going to sit out there and say, hey, for 7 days, I'm not going to accept any refreshes for this record. Of course, it's not going to be refreshed. It's dead. Our next thing, the refresh period. It says, okay, during this time, I'm going to accept refreshes and updates. And now, if by chance I powered up that VM and it came back up and registered itself back, we go all the way back to day one. If by chance I brought it up with a different IP address, it says, oh, something has changed, that's an update, it would then also automatically go back to day one. The next thing, is now we have our scavenging period. DNS says, okay, I'm going to go out there, and if my current server time plus the no refresh interval plus the refresh interval is less than the current time on the scavenging server, then I will scavenge the record. And in this case, that's not going to happen until day number 21. So if you're keeping track, that record is in DNS for 21 days. So even though I've enabled aging and scavenging and everything is set properly, that record is still in DNS. Now, what happens on day 21? Well, what happens on day 21 is the scavenging process is going to run at its scheduled time. It's going to say, hey, does April 13th plus 7 days plus 7 days, is that less than the 14 or whatever date and time of the DNS server, scavenging server is at that time? If it is, the record gets scavenged or deleted. Now, how can you tell if the scavenging process is run, what it is done, and when scavenging will run next? You'll just look in your DNS server event log, those mythical things that I covered last year. They're kind of like unicorns, dragons, and honest politicians. Most people don't think they exist, but event logs actually do exist. You're going to look for events 2502 and 2501. 2502 is going to tell you that, hey, I went out here to do a scavenging cycle, and this is what I did, and hey, my next scavenging cycle is scheduled for 168 hours or 7 days. A 2501 says, hey, I completed a scavenging cycle. I visited all these zones, nodes. This is what I scavenged. By the way, the next scavenging cycle is scheduled to run in 168 hours. Now, for some reason, I could never get a screenshot of it actually doing the process in my lab. So one of my friends, Joe Harder, sent me this from one of her customers. It's part of the only None Server 2012 screenshot in this presentation. But you can see that it has gone through and scavenged 7 nodes and scavenged 7 records. Question: what nodes? What records? Don't know. It's not recorded. Now, in the PDF, I found an article on how to enable auditing for the DNS server so that you could go and track things like that. But even on my little network, it generated thousands of event log entries. So I can't imagine what it would be like on a production network with thousands, tens of thousands, hundreds of thousands of DNS records. Man, you'd have a really hard time trying to figure out exactly what it did. But now, is the record really deleted? Not exactly. Let's go take a look at that record in ADSI edit. We're going to connect to the domain component, domain DNS zones. So here we are in ADSI edit. And then you're going to click on and expand domain DNS zones. Then you're going to click on and expand Microsoft DNS. Then you're going to click on your scavenging server, and then click on your record. And then you can right-click, go to Properties, and you'll see, if you've ever worked with Wins, it's now tombstoned. It has been deleted. It has been deleted from the in-memory cache of the DNS servers. And its actual object in Active Directory has been deleted, so you won't see it in the DNS console, but it is still in Active Directory. By setting this DNS tombstone true, it knows that whenever it goes to load the zone, it doesn't need to load that record. Now, there's a bug prior to Server 2008 R2 that if you're in a high traffic Active Directory environment where you're continually removing and adding hundreds or thousands of DNS records a day, that with this and a bug prior to 2008 R2, it will actually create another DNS record instead of reusing this record. And the Active Directory database file can grow to gigabytes in size. And the articles for that are in the reference section in the PDF. There was a hot fix prior to 2008 R2. 2008 R2 and above say, hey, if you recreate this record, I don't care whether it's a different name or whatever, I don't care who owns the record. We're just going to go out there and delete this. This record is gone, and I'm going to create another record. And that way, the Active Directory database doesn't grow out of size. And then you can see that this DNS record is in the deleted objects container, and I've got instructions in the PDF because most people don't go to the deleted objects container on a daily basis. So now we have the DNS tombstone period. It also is 7 days. So our record, while it may not exist in the DNS console or in the DNS memory cache, still exists in Active Directory. And now all of these are configurable. We can configure the no refresh, the scavenging period, and there's the registry key where you can set the DNS tombstone period. The only thing that cannot be adjusted is at 2 a.m. every morning on the time of the scavenging server. It's going to run a process that says, hey, has this tombstone record exceeded our DNS tombstone time? If it has, it's gone. So now, I added a record. How long did it take to get out of Active Directory? 29 days. So if you were to go to your office and turn on Aging and Scavenging tonight, and it would be the no refresh period, so you have a bunch of old stuff, everything's replicated, everything's good to go. It's going to be the no refresh period, then it's going to be the refresh period, then it's going to be the scavenging cycle. It's going to be 21 days from today before the records are actually deleted in DNS. So just by turning it on and coming back into work the next day, nothing's happening. It will be 21 or 22 days before you can actually go in there and take a look and see that stuff has actually started being removed from the DNS console. But wait, there's more. If you order now, just $19.99. Sorry.
See the scavenging week, is that can you still get a refresh during that week? Is it still looking for
refreshment objects? Yeah, all during that time. If it finally comes back and refreshes.
That's almost a 2-week period at the end of that.
Yep. Then yeah. So I can be on day number 21 and bring up that VM, and we go all the way back to day 1. In the DNS tombstone period, we could be on day 28, and I bring up that VM, and we go all the way back to day 1. Because it will see that that record still is in Active Directory, and it will just reanimate it. So how does DHCP play into all this DNS stuff? Well, we have the DHCP lease duration, which by default is 8 days. When is the first DHCP lease renewal period? 50% or 4 days. When's the second? At 87.5%. What's 87.5% of 8 days? 7 days. So that's why you have 7 days for everything, because Microsoft is playing it safe. That's why all this is turned off by default. It wants to make sure that everything has a chance to get refreshed, if at all possible. Now, the no refresh in the refresh intervals should be less than your lease duration time and greater than the first DHCP lease renewal time. So those two should be greater than 4, less than 8. So they should be 5, 6, or 7. Microsoft does 7 because that's a long time and gives DHCP 2 tries to get that record refreshed. Now you also have DHCP option 81, which I've also seen in Microsoft documents as the DHCP DNS options, and also called the DHCP client fully qualified domain name option. You want this set, and here are the recommended. You want it to always dynamically update, and you want it to dynamically update even for stuff that can't automatically dynamically update. And according to the Microsoft documents, this also means Mac OS X, Linux, and Unix boxes. Server 2008 R2 and higher now have name protection. What's name protection? Well, technically on the server side, that's covered by RFC 4701, 4702, and on the client side, it's covered by RFC 4361. What that means is that a non-Windows computer, if it is using our Microsoft DHCP server, when it comes up, DHCP says, okay, I'm going to give you an IP address, but I'm also supposed to dynamically register you in DNS. If this is server 1, but I've already got a server 1 in DNS, DHCP for 2008 R2 and higher with name protection enables says, no, you're not going to squat on that name. It already belongs to a real computer, a Windows server. So it will give it an IP address from DHCP, but it will not register it in DNS because there's already a record registered by a Windows computer. And the other thing is when you enable name protection, you see all the different things it's going to do. It automatically handles all the DHCP option 81 stuff. Now we have a problem. What if our records are dynamically updated by DHCP1? DHCP1 owns those DNS records. DHCP1 dies. You bring up DHCP2. That computer comes up and says, hey, I need to be registered in DNS. DHCP2 says, ooh, I can't. Those records are owned by DHCP1. I can't update them. Problem. How do we solve it? You put your DHCP servers in the DnsUpdateProxy group. And then the DnsUpdateProxy group then owns those DNS records. Problem. DnsUpdateProxy group can only do unsecured dynamic updates. If you're using name protection, you have to use secure dynamic updates. Now by default, when you enable dynamic updates, it wants to do secure dynamic updates. But now you can't do secure dynamic updates because the DnsUpdateProxy group can't do that. So now what you're going to do is you're going to set up credentials, because if the DHCP server is running on a domain controller, you need to set up credentials in order to do secure dynamic DNS updates. And this can be just a regular domain user account. So you're going to go to your protocol, right-click, go to Properties, go to the Advanced tab, Credentials, and enter your stuff there. And then now your DHCP servers will own the records, and they will now be securely updated in DNS. If you use name protection, you must protect the DnsUpdateProxy group, which Microsoft says is a good thing to do anyway if you're using the DnsUpdateProxy group. So you just open an elevated command prompt. You'll run this DNS command to open ACL on proxy updates. Run that, and it secures the DnsUpdateProxy group. Whew. That's a lot of stuff. All right, let me see if I can wrap it up for you, and then I'll ask you if you have any questions. So here's what we're going to do. If you're using Microsoft DHCP, Microsoft DNS, and Active Directory, which I assume most of y'all in here are doing Active Directory, you want DHCP to control and register all DNS records. So in order to do that, we're going to put all of our DHCP servers in the DnsUpdateProxy group. We're going to use DNS credentials so that that DnsUpdateProxy group can do secure dynamic updates, and then we're going to protect that DnsUpdateProxy group. Once all that's done, our aging and scavenging has been set on the server, has been set on the forward lookup zone, on the reverse lookup zone. You've set your scavenging server, you've enabled scavenging on that server. Your server is getting accurate time, and everything is good to go with aging and scavenging, and things will start being deleted properly with no errors recorded in the DNS or DHCP servers event logs. Questions? All right, let's go on to question number 2. All right, we're going to briefly review single domain, single site, single domain, multiple sites, multiple domain, multiple sites, and then we'll put it all together. So to review what we covered last year, this is actually a very prominent design. It's just a single domain with a single site. Active Directory likes two things. Active Directory likes simplicity, but most importantly, Active Directory likes consistency. Above all, Active Directory wants you to be consistent in how you configure stuff. So in this example, what we're going to do is we're just going to pick a domain controller to be our primary DNS server. I always select the PDC emulator because even though all Active Directory controllers are equal in Active Directory, the PDC emulator is the most important domain controller because it's your authoritative time server. When users change passwords, that goes immediately to the PDC emulator. When a user authenticates to a domain controller and fat fingers their password, the authenticating domain controller has to ask the PDC emulator, hey, did by chance the user change their password and I haven't been updated yet? And then account lockouts go to the PDC emulator. So the PDC emulator is very important and very critical. It should be your most highly reliable, highly stable, highly available domain controller that you have. So we picked it to be primary. We're going to pick another domain controller to be secondary. And then we're going to have every domain controller, including the primary, point to the primary domain controller for primary DNS. And then every domain controller, including the secondary domain controller, will point to the secondary for secondary, and then they'll all point to themselves to the local loopback address for tertiary DNS. And that's simple. Does it have to be that way? No. You can do it however you want to do it as long as you're consistent and all domain controllers are configured the same way. One of the biggest issues I find when I go to do assessments is, in this instance, we've got 7 domain controllers. And I'll find all 7 domain controllers are configured completely different. And that's a mess. So now what do we do if we have a single domain with multiple sites? Again, these are just recommendations. What we're going to have is every domain controller is going to point to itself for primary, and it's going to point to another domain controller in the site for secondary, and they'll all point to their local loopback for tertiary. And then what if we have our remote site that has just a single domain controller? That domain controller is going to point to itself for primary, back to a domain controller in the central site for secondary. In this case, I'm using my favorite, the one I pick on all the time, the PDC emulator, and then it's going to point to itself for local loopback. The issue I have in this is that WAN connection going back to the central site. Remember what I said. This single DC is going to be the authenticating domain controller for all users in the remote site. If a user fat fingers the password, this domain controller always has to go back to the PDC emulator to determine, did the user change the password or did they fat finger it? Meaning it's always got to go across that WAN connection. This domain controller, if it doesn't think it is the authoritative time source for that site, then it has to come across that WAN connection to get authoritative time from the PDC emulator. The other problem is most people wind up having issues with these remote sites, and then they just say, screw it, and they just power down the domain controller. Or they'll just remove power from it, and then they wipe it out without ever removing it from Active Directory. Now we've got an orphan domain controller. Now replication is screwed up. Group policy is screwed up. DNS is screwed up because everything in Active Directory still thinks we've got a live domain controller in this remote site. KCC is going to go nuts trying to generate replication topology to a site that no longer has a domain controller because they always forget to remove the site from sites and services. Now, what if we have a remote site with multiple DCs? In the remote site, every DC will point to itself for primary, another domain controller in that site for secondary, and they can all go back to the central site for tertiary, or they can use the local loopback. It all depends upon your WAN connection back to the central site. Now the doozy, multiple domains with multiple sites. Now for this example, I am assuming that our A domain over there is our forest root domain, and that domain B is just a child domain. In order to do name resolution, in this example and in the PDF, we are going to be using secondary zones for each of the other domains. We could use forwarders, but once you set up a secondary zone, it's set up on all the other domain controllers. Forwarders are set up on each server. So if you're going to use forwarders, you have to go to every domain controller and configure the forwarders. So for this example, just for simplicity, we're using secondary zones. Even though they won't come into play for anything we're fixing to, I just want to let you know how name resolution would be handled for this. So here, every domain controller is going to point to itself for primary, another domain controller in its domain for secondary, and then a different domain controller for tertiary. And then when we add our remote site, at the remote site, each domain controller for each domain is going to point to itself for primary, the other domain controller in that site for that domain as secondary, and then it can either use local loopback or, depending upon the WAN connection, it can go back to the central site to a domain controller in its domain for tertiary. And then also think about the way time hierarchy is for multiple domains. I'm going to assume that DCA-1A is our forest root PDC emulator, so it is the authoritative time server for the entire forest. And then DCB-1A is going to be the PDC emulator for that domain. But the only domain controller that's configured as the authoritative time server is DCA-1A. You don't configure any other domain controller for time. They all use the default time hierarchy, which means in domain A that 1B and 1C will go to 1A for time. 2A and 2B, because they're in a different site, use a different calculation. And there's actually calculations in one of the references. The PDC emulator, root force PDC emulator, gets a value of 8, and because it's in that site, it gets the site gets a value of 1, so therefore the PDC emulator in that site gets a value of 9, meaning it's the most authoritative time server. All the others, domain controllers in one domain, domain controllers in another domain, are they in this site or in a remote site, get different values, and the lower the value, the less authoritative it is. So workstations that are in the central site for domain A will go to 1B and 1C to get their time. They do not go to the PDC emulator by default, unless for some reason they can't reach 1B or 1C, then they'll go to 1A to get their time. And the site 2, the workstations over there for domain A will get their time from either 2A or 2B. And then over here, DCB 1A being the PDC emulator, 1B and 1C will go to 1A. 1A is the only other domain controller that will go all the way across and go over to DCA 1A for authoritative time, because the PDC emulator never goes to itself for time. It always has to go up, and DCA 1A is the authoritative time server for the entire forest. So when you're doing all these designs and stuff, you always have to consider where that PDC emulator is for each domain, because of how important I've told you that it is, and also for the time hierarchy. And what I find is that people will take domain controllers and remote sites and configure them to be the authoritative time server. Or they'll just configure every domain controller as an authoritative time server, which is ludicrous, because by default, it's only going to go one place, the PDC emulator. And when you bring up, if you're creating a greenfield domain, and you bring up the very first domain controller, it is automatically going to be the PDC emulator, and you'll instantly see errors in the system event log saying that, hey, this is the PDC emulator for the root force domain, and it's not configured as the authoritative time source. So it's instantly going to start telling you in the event logs. And then when we add our second site, it's the same as site 2. Each domain controller is going to point to itself for primary, another domain controller for its domain in that site for secondary, and then you can either use local loopback or come back into the central site for tertiary. And doesn't matter which domain controller they hit, nah, not really. Just be consistent. Configure them all the same. Active Directory loves consistency. Now, what is the weirdest, well, no, that's not the right word. What is the most difficult AD assessment I've ever done? I got brought in to consult for a company doing actually a greenfield installation, meaning everything's from scratch. It's all brand new. All they've got are domain controllers, no servers or anything else yet. They had 8 sites, all in one geographic area. Each site was connected to the central site via redundant 300 meg pipes. And what they wanted to do is they wanted each site to be a separate domain. And they wanted 2 domain controllers from each domain in each site, which means there would be 128 domain controllers. So I actually was able to draw that out for you. I like this tweet by Mark Naus. Do any of y'all follow Shane Tech on Twitter? If you do, you can tweet him and tell him he's now getting his street cred at BriForum London. He says the IT architect's job number 1, do not introduce downstream operational complexity or business impact for the sake of the technology or your design ego. This was purely the ego of the 2 guys heading the AD team for this company. Because all 8 sites were in the same geographic area. They had 300 megabyte redundant pipes between all the sites, going back to the main site. All of that could have been one domain, one site. They didn't even need to have 8 sites because they're so well connected. Everything could have been done with one site. One site. You could have had 2 domain controllers at each of the other 7 locations, so you would have only had 16 domain controllers instead of 128. I can't imagine the change management control for patching and updating and maintaining 128 domain controllers for 8 different domains. I mean, that is stupid. And I basically told them that what they needed to do was get Microsoft Consulting in because they weren't listening to me. Because I know exactly what Microsoft Consulting would have told them. You got 8 sites, you got one main site, all your sites are connected with 300 megabyte redundant pipes. You could do it with one site, one domain, one site, use OUs for all 8 sites to handle your management and everything, and then let KCC handle all the replication, topology and everything. And then you don't have to worry about inter-site topology generation and all that stuff. And with 300 meg pipes, I mean, there's no latency when you go to do replication. So now that we have all those sites, now what? Actually, you need to make sure you have created all your sites. Create as many sites as you need, but as few as possible. It's kind of like most design decisions, like when you're creating, a XenApp farm. How many zones should you use? How many zones should you have? Well, as many as you need, but hopefully as few as possible. It's the same thing with sites. Have as many sites as you need, but as few as possible. If you've actually got 2 sites defined in sites and services, and they're in the same town, and they've got a 10 gig pipe between them, they don't need to be 2 sites. They can actually be one site. You know, just because they're separate physical locations doesn't mean you have to have sites for them defined. Now what you need to do is go in and create all your subnets. This is probably the most problematic area that I see when doing an assessment. You need to make sure you have all your sites, because what happens when people bring in subnets and stuff into the network, the routing team always knows, the firewall team always knows, the web filtering, content filtering, you know, all those people know about all the subnets that are being added to the network. No one ever bothers to tell the Active Directory team, hey, you know, we're going to add a 10.4 subnet over in this building we just acquired. You can also create catch-all subnets. This doesn't work in a lot of very large enterprises, but you can create a catch-all subnet. So say for this example, we've got 10./8 for the central site, 172.16/12 for site 2, 192.168/16 for site 3. What that means is, if we know, well, once you create catch-all subnets, you should always have specific subnets, even when you have a catch-all. So if in the central site, if we're using 10.1, 10.2, 10.3, we can have a 10./8, but you still need to have a 10.1, a 10.2, a 10.3, whatever mask that you're going to use. Because then when all of a sudden they go out and buy a building and acquire the 4th floor, and now they're going to add a 10.4 to it, you're going to catch it, and it's going to go to the central site automatically. But then, being the diligent people that you should be in Active Directory, you're going to be looking in C Windows debug netlogon.log and going down to the bottom, and you're going to see all of a sudden you've got 10.4 IP addresses authenticating to your domain controllers, and you're going to go in and add the 10.4, because it is also possible that the 10. Could cover, say, site 2 and site 3. And you've got a 10.1, 10.2 for site 2, and a 10.4 and a 10.5 for site 3, and someone brings up a 10.6. What site does it go to? You need to figure that out, and you need to put it into your sites and services. The most important thing, create site links. As smart as the knowledge consistency checker, KCC, is, it knows nothing about your LAN or WAN topology. Completely ignorant. So you have to tell it. So in this case, I created a central site to site 2, a central site to site 3, and a site 2 to site 3. And then you'll notice my cost that I've got. My site 2 to site 3 has a cost of 500. What does that mean? If I'm going to go from central site to site 2, it's got a cost of 100. Central site to site 3 has a cost of 100. If for some reason site 2 needs to do something over to site 3, that's going to go from site 2 up to the central site down to site 3 at a cost of 200. Because KCC knows that we don't send any replication traffic from site 2 to site 3 because it's got a cost of 500. Now, if something goes wrong and the link between central site and site 2 goes down, now the KCC says, oh, okay, I have a way to get from site 2 to site 3. We don't have isolated domain controllers now. And then we don't have to worry about domain controllers being offline and stuff like that, because that happens a lot more than you would think. And people wonder why logon performance is so slow when a site link has been down for 6 months and they never bother to check event logs to actually realize it. Next thing you're going to do is actually place the servers in the sites where they should be. And in Server 2012, during the domain controller promotion process, you now can pick the site the domain controller should go to. But if you got all your subnets created beforehand and you got your sites mapped properly to the subnets, when you bring up the domain controller, it should know by its IP address which site it should be placed into. Now, we're just going to sit back and let the KCC do its job, and we're going to stay out of its way. How? Great question. Glad you asked. First thing, we're going to check our domain and forest functional levels because we're going to get off those old forest and functional levels so that we can get more efficient KCC replication topology and more efficient replication traffic and better use of our security groups by being able to have more members in there, and we can control. In the old ones, when you made a change to a security group, that whole security group replicated around. When you go up, it will replicate just the attribute that changed in the security group. So we're going to get better replication traffic. We're going to make sure that all domain controllers are global catalog servers in a multiple, even in a multiple domain environment. And people say, well, what about the infrastructure master? If all global catalog servers, if all domain controllers are global catalog servers, infrastructure master has nothing to do. Infrastructure master is there to keep track of phantom objects or deleted objects between domains. And that's when all domain controllers are global catalog servers, that doesn't happen. Global catalog, remember, keeps a partial representation of every object in your Active Directory forest in an in-memory cache. So get off those 32-bit domain controllers. And we're going to have no manually created connection objects in sites and services. There should never, ever, ever, for any reason, be a manually created connection object in sites and services. If you think you have to have a manual connection object between domain controllers, then you have something wrong in sites and services. You either don't have your sites defined right with the right subnets, you don't have site links generated to let KCC know how it can actually go out and connect all the different sites and all the domain controllers. You need to fix your issues in sites and services before you create manual connection objects. And then on a daily or weekly, monthly, whatever, on a regularly scheduled basis, you're going to go to C, Windows, debug, netlogon.log for every domain controller. Open that file up, Notepad, whatever editor you use, go all the way down to the bottom, and you'll see the most recent entries for that file. Those recent entries are IP addresses from computers that have authenticated on that domain controller. And that domain controller may not be the optimum domain controller for that client who have authenticated with. So fix that. And then once you get all your subnets, Active Directory will live on forever without ever having a reverse DNS lookup zone. But if you're using XenDesktop or View or AppV or vSphere or vCenter Server or lots of other software that we use in our world, they all either require or work best if you have reverse DNS lookup zones. And of course, once you create a reverse DNS lookup zone, you're going to right-click on it, go to Properties, and you're going to enable aging and scavenging for that zone. And then we're going to clean up DNS of unnecessary duplicate host names and IP addresses. And we're doing that by properly doing our aging and scavenging and then making sure whatever we're using for DHCP, that DHCP is handling the secured dynamic registration for the DNS records. And then we're going to clean up orphan domain controllers. Your event logs are screaming at you for these orphan domain controllers. KCC is telling you that it can't generate replication topology. Domain controllers are saying that I can't reach my replication partner that the KCC says I'm supposed to be able to reach. So you have to clean up these orphan domain controllers in order to resolve a lot of the replication issues that are out there. You're going to make sure that PDC emulator is configured properly. You want it to be in the root forest domain. You want the PDC emulator to be the authoritative time service for your entire forest. No other domain controller or server gets configured as an authoritative time server unless you are using something other than W32 time for your time service, because W32 time is not very accurate and it's designed not to be accurate. Microsoft tells you that it's not very accurate. The only thing W32 time guarantees is that Kerberos will work. That's the only thing Microsoft guarantees. Then you're going to make sure all your domain controllers have their DNS IP settings configured properly. What I showed you were just recommendations. Just remember, Active Directory loves consistency. Make sure all your domain controllers are configured the same way. There are people who will check the box, enable LM host, lookup, and they don't use wins. Or half the domain controllers will have the IPv6 protocol unchecked and the other half don't. You know, so just make sure everything's configured. They're all pointing to the same thing for primary, secondary, tertiary. Just be consistent in how you implement the stuff. Then you're going to use Microsoft and other vendors' Active Directory design guidelines. Whatever product you're using for your desktop virtualization or application virtualization or your user environment management, they all have specific guidelines of how they want things set up in Active Directory. So you need to make sure you're following your vendor's recommendations to make sure that you're getting the best use. Therefore, your users are getting their best experience out of your desktop and application virtualization efforts. Whew. Question time. Questions?
In the DNS system, you mentioned point DNS server to self and the tertiary use loopback. What's the point of pointing its IP and its loopback address?
Because Microsoft says to do that. If you run the Active Directory, well, this is the thing where two Microsoft teams don't talk to each other. The best practice is the domain controller should have its IP address, you know, and then the loopback should be, you know, the tertiary. When you promote a server to be a domain controller, the DC promo team didn't listen to the other team, and they'll set the primary IP address on that domain controller to be 127.0.0.1. And then you go and run the best practices analyzer, and it says, no, your domain controllers are all configured wrong. You know, you're supposed to have the domain controller's IP address as primary, and you use the loopback for tertiary, and you need to have something else for secondary. And it's that way, basically just to get a clean report from the Active Directory best practices analyzer. Because if you configure it, and then if I were to come in and configure all the domain controllers to have the local loopback as primary, then the customer goes and runs Microsoft's best practices analyzer, then they're going to come screaming at me, hey, you know, we're failing. So the auditors are complaining that our stuff's not configured right. You configured this stuff. Yeah. Any other questions?
Time for about 2 more questions.
Another one, if you delete your manually created connections,
Mm-hmm.
domain controllers, how long before the KCC will kick in?
KCC.
KCC will kick in and fix it?
Usually within a couple of seconds. I did that for a customer. I actually had their stuff to show, but they actually had 10 sites, and they had nothing but manual connection objects between all the domain controllers in all 10 sites. And group policy wouldn't replicate, DNS wouldn't replicate. They would add a user, and it would be days or weeks before it would show up on another domain controller. And what I told them to do was just go out there, fix. They were missing hundreds of subnets in sites and services. I mean, hundreds. They had to add, I think they had almost 10,000 IP addresses. When I consolidated all of their netlogon.log files, then you can go into Excel and then have it sort everything and then remove all the duplicates. And they were left with over 9,689 IP addresses that were, so they had a lot of cleanup to do. Once they fixed sites and services, they deleted all the manual connection objects, and within 15 seconds, KCC had gone out, done its thing, and then literally in less than 15 minutes, group policy, DNS, everything was replicating within 15 minutes. So you need to stay out of KCC's way. KCC is very smart. It knows what to do. You just got to get out of its way. And yes?
Is there something you can do
It's in the deleted objects container. To be honest, I don't know how you delete something out of the deleted objects container.
Well, it sits as an object in AD, as a live object,
Right,
but it's not in DNS, it's no longer on the network, it's
Right.
a dead machine.
right.
But it just sits there.
Yes, for 7 days for the default tombstone period. After that 7 days, it then gets purged out of the bowels of Active Directory.
Okay.
All right, any other questions? Well, thank you very much for coming, and don't forget to fill out your surveys. Thank you very much.